Hello, so today the topic is actually going to be on tangencies and circles. Now, in this example, we have an object which incorporate different aspects of tangency and circle knowledge. So, what we're going to be looking at here is the three main areas that are going to be tested. One, if you look around this region here, you can see a tangent to two circles, and if you don't know what a tangent is, we will be diving into that as well. We will also be looking at how to get this curve here, which seems to be touching both circles, and the center point will be around this region here. Now, in the original example, we would not be having any of these construction lines, and we'll have to start from the basics. Now, for this outer curve here, we'll also be constructing this using a similar method to the original one, but this one will be in the opposite. So that's just basically a summary of what we will be going over. All in all, it's going to be around circles and tangencies. Now, let's go across to, don't mind this, this is, we'll be working on that as well. So let's start with our tangency question. Yeah, so what I'm going to do right now is I am going to, let me just turn back on all of the layers. Nice. So now that I have on all of the layers, wait, I'm gonna go to the construction. And what we're gonna do is we're just gonna draw two circles. And we're gonna make sure that we know the diameter of the objects. And let's draw another circle here. Let's probably give this one 20. Yeah, nice. So let's have a little chat. Now this talk is going to be on what exactly is a tangent, and we're not going to stay too long on it, but we're going to run through it very quickly. Now a tangent is basically a line or a plane that passes through one point on the circumference of a circle. So for an example, a tangent could be, if this was a wheel, a tangent could be simply the straight road that it runs along, where it just touches that one microscopic point at the bottom of the wheel of our car or whatever it is that we're riding, or even a football rolling along a field. Nice. So for this circle, a tangent could also be, doesn't have to be exactly horizontal. A tangent could be along this angle here. Yeah, so these two lines are tangents. Now let's see if we can understand this a bit more. Tangents can also run, let's just say, through a particular point. If there's a point on if there's a point somewhere random in space, I'm gonna say, hey, I want a line that passes through this point and touches or is tangential to this circle. What I would like to do is I need that line to pass through one singular point on the edge of my circle, which in this case would be here. Now, one of the things I would like to show you is that your tangent, I'm going to switch across to layer 2, layer 1 for this. What I want to show you is that your tangent is not always, perpendicular to, you see, to a vertical or horizontal plane. It's not always at that right angle. However, it will be at a right angle from the point of tangency. So that's one there, that's the vertical line, and this one I'll enter. If I make this come here, if I measure this now, nice, we can see that we have that 90 degrees at this particular point right here. So simply speaking, the point of tangency is where the line that also passes through the center meets the point in the circle that is common with the tangency line. Yeah, awesome. So now that we basically kind of know how to identify a tangent, I almost forgot one more thing. A tangent cannot pass through the circle twice. So we're dealing with one common point between this line and this circle. For those of you who need a visual representation, if I run a line very, very close, meaning this particular line right here, let me just highlight it for you all in orange. This line is not a point of tangency, and it cannot be a point of tangency simply because there are 2 points here and here where this particular line is crossing through the circle. So be very careful when it is that you draw your tangency lines. Nice. Now that we got that out of the way, let's look at other ways that we can actually have tangents. Now, since we looked at a tangent passing through a particular point, we can also now say a tangent could go from one circle to another circle. All we need is the common points between the two of them, where that, or what we'll call or refer to as the point of tangency for the both circles. Now, just for example's sake, because we're going to get into the construction of it in a bit, I'm just going to use the AutoCAD command, and for those of you who do not know, it is enter. I'll enter. So let's just say you're going to make your line, then you're going to go TAN, which is for tangent, then you're going to click it here, and then you're going to go to another circle and click TAN, and then you're going to click that area as well. So this is what is called an external tangent to two circles. An external meaning the line itself is on the outside of both of the circles, which means circle 1, circle 2. And since there is an external tangent, you may be thinking, but sir, does that mean that there is an internal tangent? And to that I would say yes. So if I go again, I'll enter TAN for tangent, and I'm allowing AutoCAD to choose the point of tangency, and I put TAN again, and I line it up with this one here. What you can see is this is now an internal line, meaning it passes through the axis of the both circles. Like if I draw a line, let's see if I could do it here. I'll enter. So if we call this space here, wait, nice. If we call this space between the two centers, like the between space of the two circles, then this one is an internal one because it passes through the inner workings of the two circles, and this one is an external one because we see it stays on the outside of the two circles. Yeah, nice. So we have TN, G and T, sorry, text. So here we have TXT. So here we have the external Right, so we have the external, we have the internal, and let's just grab this one here, and this is just a regular tangent. Copy this, and this right here, this is the point of, did I spell that correct? No, I did not. Alright, so this right here is the point of so this right here is the point of tangency. So one more change. Nice. So this right here is the point of tangency. Let me just mark that. Awesome. So here, and this right here will be the internal tangent, Nice. So as you can see, the point of tangency is at 90 degrees from the center point of the circle, touches the circumference. So which means yes, this is radii and passes through the just passes through that one point on the circumference. Nice. We also have our internal and we also have our external angle, external tangent for reference. So now that we understand the basics of exactly what is a tangent, we're going to go across to construct our first tangent. And the first one we're going to focus on for this particular video will be the external tangent. We're going to do internal tangents at another day, but we're going to do the external tangent to two circles because it's relevant for our question that we will be doing today. So we're going to go back across. We're going to go to a new space and we're going to look at the question that we have in front of us, and we will be starting to construct some of the basic shapes. When we are drawing, I would say the most basic things, especially if we are asked to replicate a particular drawing, will be to start with the basic shapes. So in this particular shape we have circles, so we're just going to start with the center point of our circles. I'm going to take any center point for the circle. I'm going to zoom in. I'm going to draw, let's just say, a line that is slightly bigger than a diameter, so let's just say 70, and we're going to go down 70. I'll enter. We're going to go across 70 as well. We're just gonna make sure that these two line up. Nice. And then once we have this, now we can continue building off of this. So I'm gonna switch across to my construction line, C, and I'm gonna do the inner circle. The inner circle has a diameter of 34, so therefore that is a 17 radii. So we're going to do 17 there, and C enter for the bigger part of it, and it's going to be 60, so that is 30 radii. So there we have the two circles for this particular one here. We're going to put those one time in the object outline because this is actually solid parts that we're going to be drawing. It's not necessarily intended to be construction. And now from this we're going to use our dimensions given to build further on the drawing. So here we understand, I'll enter, we understand that the distance, in fact from here to here, meaning 20 up, going up 20 and going across 20 would give us one of the lines will be passing through the center of one of our other circles, which is on the left hand side, the highest one. Wow, I'm really thinking of my words. And then we're gonna go, we know that going down 45 will also give us what other line, which will be passing through the center of our lower circle. And last but not least, if we go across 90, because we're given the dimension of 90 degrees, we're given the dimension of 90, so we're just going to go, just make sure that that line is 90, I'll enter. So we're going across the 90, no, can't you see, I'll enter, we're going across from here, going across to like 90, and then we're going to go up to here. And then what we're going to do is we're going to go 18. We're going to begin to construct the other two circles. Now I like to copy my center lines across, C, O, enter, and then I'm going to copy the center lines, and we know that one of our circles is going to be here and the other one is going to be right here. I'm going to TR and enter. I'm just going to trim this line and this line right now. So this will be now be the center points for our two circles. So now what we're gonna do is we're gonna simply take this. So now we're gonna use these two as the center points, and we're just gonna simply start with a circle. We're gonna come from the center. No, I think I was starting down here first. Nice. So we're gonna come from here. We're gonna go 9. Because the diameter is 18, and then we're gonna go 20 because the other diameter is 40. Now once we complete this part of the drawing, now we will be going up to our higher circle, and this will now be circle. Once we're doing this one, the innermost one will be 12 because the diameter is 24, and then we're also going to use, because it's 54, we're going to go 27, which is half, and there we go. So now, just for reference sake, we're gonna pull some, let's see, the diameters for all of these circles. We know this one is 54. We know the next one is going to be 54. This one is 24. We're gonna go from this one here. We're gonna go 18, as well as we're gonna go 40. Now we're gonna go on the last one, and we're gonna say this. We're gonna say, hey, this one is 60, and then I'm gonna hit enter just to redo the command, and that one is 34. So looking back, I understand I would have gotten all the dimensions correct. So now, because we have this, we will be constructing a tangent from our question to these two outer circles. Yeah, from this one here and this one here as well. So let's take a side and let's go to the clear space, and let's go over exactly how to construct an external tangent to the two circles. So I'm going to create two circles just roughly by here. I'm going to go, one is going to be 50, and then I'm going to use circle again. I'm going to go here, I'm going to go 20. If you're seeing me using the ribbon on the top of here to pull my commands, I will not recommend it. I would like you all to actually get practice doing your commands from the command line, which is at the bottom here, or just typing in your commands. It makes your drawing a lot faster. So now that we're going to start from here, we need a tangent to these two circles. So we're going to start off by just going to be a bit lazy. I'm just going to grab my center lines from here, COP. We're going to copy this, we're going to grab it from the center here, and then we're going to use it here. For you, you can draw it over and you will be fine. Nice. So now what we're going to do is we're actually going to go over the construction for an external tangent. Now you have two, and I'm going to just grab the diameters from here just so that we can see. One is 100, one is 40. Nice. So now you have two circles, and the first thing you need to do is, one, you're going to draw a line going from the center of one of the circles to the other circle for me. So you're going to go L enter, you're going to just grab a construction line, you're going to put it to the center of the both of them. Yes, so once they're touching, you can see, nice, that is the center of the both of them. Now what we're going to do is we're going to bisect this line to get a 90-degree angle in the center here. So we're going to do that next. 90-degree angle, I'm looking for the center of this line. Main thing, because what we want to do is we want to draw an arc from one center of the main circle to the other center of the other one. So we go to center start end, we go slightly above halfway point. I would recommend at this point here, you could just you can eyeball more than half, and once you do that, you could always look at, hey, 80 looks like a decent number because you have to remember the radius of your arc, especially when bisecting. So we're going to go 80 out, and then we're going to cut. Now we're going to do the other side, where we click here, we go 80 out, and then we cut through. Now if it is that you see this, you can simply hit shift, wait, no, okay, so I'm going to go escape because I'm supposed to be able to hit shift to change the direction. So we're going to go from here, 80 out again. Okay, so nice. So right where we cut the two of them here, we draw a line coming from this line to this line. Now this is if you would like to show the construction. Now remember, what we're doing is we're actually showing the construction. Yes, AutoCAD can be snapped to 90 degrees on this line, but we want to show that we're competent, so actually going through the actual construction to get a perpendicular line at the center point for this particular line. So now that we have the center point here, now we have this 1% center point here, we're going to use that as the center point for our new arc. We're going to go from here and we're going to touch through on this side here. And now that we have this is just the beginning. So we're going to pause on this particular first step here. I'm going to go across to the second step. Now the second step includes us and a little bit of calculations in order to finish it off. So we know that the diameter is 100 and the big circle is 100, and for the small circle it's 40. So what we have to do is, and TXT, for this particular part, we're going to construct a circle that is, we're going to use capital D minus small d is equal to the new diameter. In fact, we're going to go capital R minus small r will actually be equal to let's call it the tan r. Enter. Oh nope, TXT, I was typing it in the wrong place. Nice. So we're gonna go here, we're gonna say capital R minus small r is actually going to be equal to, let me just put a little space in between that one. Capital R minus small r will be equal to tan r, or the tan, let's just call it that tan radius. Yeah, no, right, like I said, capital R minus r is equal to tan r. Nice. So this is what we have here. Nice. So using this formula, we're going to construct a circle inside of the bigger circle. Yes? So inside of here, inside of the bigger circle, we're basically gonna get the difference between this circle here and this circle and construct a circle inside of that, a concentric circle with that difference. Let me show you what that looks like. So I'm gonna switch across to my layer just to show you the difference, and now I'm gonna go TEXT. I'm gonna come here, I'm gonna show you big R would be 100, big R would be 50 because the radius, if the diameter is 100, is 50, and small r would be, since it's 40, will actually be 20, which gives us, a difference of 30. And once we do this, enter, escape, we now know that the radius for our circle on the inside would simply be to there. And just for dimensioning purposes, let's grab a linear dimension and we're just going to measure the distance between, which should be equivalent to the radius of this internal circle here. Yes, awesome. Nice. So now that we have this going on here, I'm just going to delete this and I'm going to go back. Now there's a particular point at this point in our construction that we will need to look at. We need to look at this here, point, the point where our circle, our tanner circle, meets our larger arc, which is the arc between the two center points, that touches the two center points. We're just going to put a point there. Now this, if we draw a line passing through the center of the big circle, also passes through this. Let me just go here. Then I'm going to click this. I'm going to lengthen it, and I'm going to lengthen it going upwards. Nice. Now this point here will actually be our point of tangency. So where the arc meets the tanner circle, if we extend that line up further, we actually get our point of tangency. And at this point we're almost finished, but now we need to also get our point of tangency for the other circle. And all we do is we simply grab the line, we're going to copy it, and now we're going to use the base point as the center point, and we're going to copy it across to the smaller circle, point, and we're going to put a point right here. So now that we have this line would have just been transferred across. We know that the point of tangency for the bigger circle is here, and the point of tangency for the smaller circle is simply on this one right here. Now what you can do is enter, and at this point you could draw it coming into here, and then you will actually have both circles. Sorry, the tangent. After you have the tangency point to both circles, you now get the line of tangency, or the external. Let me just put this in object outline. Nice. And let me just also put this in object outline. Nice. And that is how you construct. Yes, and that is how you construct the external tangent to two circles. Now we have this little understanding going on here. We would have gone over this particular part. Now it's time for us to go back to our drawing and to our point of tangency for this particular part. So I'm gonna put these to main object outline, then we're gonna zoom in, and we have to do everything that we just did. We're gonna do it on this side. So I'm just going to switch this across to construction green, and you can follow along. So I'm going to go here, then we're going to center start end, we're going to go slightly above, I'm going to go, the center point is here, I'm going to go 60, I'm going to cut here, and then I'm going to go arc again, and then I'm going to go here, and then I'm going to go 60, then I'm going to cut, EX, enter. If it is that you realize that your lines don't touch each other, your arcs don't touch each other, just use extend and extend the lines until they touch if you are in AutoCAD. Next step will be to grab the line from here and also put it down here. Once you do that, you can come out, and we now know that we have this here. Then we're going to grab this, we're going to come here, we're going to touch here, we're going to make this on the outside right here. Then of course we now have to do the calculation. Right, then of course we have to now do the calculation, which will be we're gonna type up here TXT, and we're gonna come across here. We're gonna see 60 radius 30 minus, in fact, bigger minus smaller is equal to 30, and is equal to 10R, enter, which will be 30 minus, I believe the other one was 20, the other big circle was 20, it's actually equal to 10. Enter, escape. Nice. So this would have been a calculation. So now I change my line layer so that I could see better. See, enter, and I hit a circle of 10. And once I have this, I have my common point. I grab my common point, which is right here. I'll enter a line from the center to the common point. Establish that. Then I'm going to click the line. I'm going to have this. I'm going to click lengthen, and I'm just going to lengthen this line slightly above. Nice. So now that I have the first point of tangency on this side, now because I'm an AutoCAD and I can copy, if it is that you're doing this on paper, you could also just use a combination of your ruler and your 60 30 and just slide the line across. Alright, so I'm gonna copy this. Alright, I'm gonna grab the base point at the center, then I'm gonna put it across right here. Nice. And then I'm also gonna go point. Then I'm going to zoom in on this particular part. I'm going to have my point of tangency. So now I have my 2 point of tangencies. I'm going to switch to my main outline. I'll enter, grab this from here to here. Awesome. And that's how we construct this line in the bottom here. Now, so this and this, these two things, as you can see, pretty straightforward. And now what we're going to do is we are going to simply start doing the other two arcs to complete our drawing. Now we do have to work on another concept, so I'm just going to come across and I'm just going to go up to around here. Nice. Nice. So now let's do a bit of circle theory, which is needed for understanding the other part of the question. So what I'm going to do is I'm going to introduce to you the idea of the magic circle. So we're going to do a circle of 50, so it's 100 diameter circle. And since it's 100 diameter circle, let's talk about this. So I'm going to switch from outline to construction. Nice. So I'm gonna switch from sorry, I just looked at something. Right, so let's talk about this particular circle. I'm going to draw I'm not gonna draw the center line. Let's talk about this. A circle is a very interesting object, and if it is that I do, let's just say, another random circle and call it like 10, right, on the outside, I know for sure that there are different ways that these two objects relate to each other. If you're in physics, you'll be like two big bodies, gravity and stuff like that. But no, since you're in technical drawing, things that are relative to us will be the centers of the object. So we know that, hey, we would have had a distance between the center of the objects. So this could be the sun, and this could be us, or this could be us, and this could be the moon, or Earth and the moon. So we have a distance between the center of the Earth to the center of the moon, technically, and this distance comes with a particular dimension, and let's call this 116.3 whatever miles across, right, from center to center. But that's interesting. Yeah, so what we're gonna do is we're just gonna delete this, and we know that there's a distance between here and here. Let's understand that mentally. But what will happen if the moon was supposed to just come and rest on the earth. Like if we had the moon actually just touching it, like what would it be like? I'm gonna copy this and I'm gonna grab this here and I'm gonna rest the moon right on top of our earth. So it's both of them are basically touching at this point. No collision, no big Armageddon type situation or doomsday situation. We just simply gently rest the moon on top of our earth. And if we look at the same thing, the same property that we were looking at with regards to the centers, the difference between the centers, we could go from here to here. And this is interesting because now if we pull the dimension for this one, let's just pull it across here. If we pull the dimension across for this one, we see a distance of 60, and we'll be like, I feel like I've seen that number somewhere. And it seems familiar simply because what we do is it's the distance from this center to this one, which is 50, and from this one to this one, which is this. Don't mind the little exclamation mark, guys. Oops. Alright, so don't mind the little exclamation mark. We'll deal with that another day. But for now, we're just gonna focus on so from here to here is 10, and from here to here is 50, so which means 50 plus 10 is 60. But we also, again, we saw those numbers somewhere already, which is why it looks familiar to us. And it looks familiar simply because if we take the radius of this is 10, and if we do the same thing for the bigger circle, the radius for this is 50. So this is why the numbers look familiar. It's actually the sum of the two radius. Yeah? And I find this to be very interesting, which also means that if it is that we dig a very big hole, COPY, and we take our moon now and we bury it in our earth. Oops, let me just grab this again. Right, so if we take another point now and we bury it in our moon, we bury it at somewhere inside the ground, but we just put it so that the top of the moon just peeks out the surface, and then we look at it, or like, oh well, okay, let's do our same analysis, and pull the differences and see what we come up with. So we know that I'll use this one. We know that the distance from here to here is 50, because that clearly is 50 because it's the radius of the big circle from center of the big circle to the outside. But now if we do the difference from this one here to, let's see, the center of the circle, which is here, it's going to be 40. And now this number looks familiar, because remember in this example we took from center to center the circle. From this example up here we took from center to center the circle. So for this one, this is from center to center, but the number is different. The number is smaller, and smaller by 10, and we know that the distance from here to here is actually 10. So there we could clearly see, just ignore the exclamation marks, we could clearly see that since the difference from here to here is 40 and 10 is 50, we know that if we were supposed to write this down, it would be on one half here we're adding up the radius of the two circles, and on the other half we're gonna minus the radius of the two circles. And this is a very key important part, simply because it's how we're going to be constructing the other two parts for our object. Just a little circle theory here. So let's go across to our open space, and what we're gonna do is we're gonna draw another circle here. We're gonna basically draw the same circle of 50, and then we're gonna draw a circle of, let's just say 20. Alright, and now what we want to do is we want to make an arc for that that touches these two circles, and we just don't know how. So again, we could say, just like our example before, we could say, oh well, the distance between from here to here and distance between from here to here is, the same thing we were looking at from before. But that doesn't give us, exactly where we should draw um, our arc from in order to get the arc. But what I want to introduce to you is that there's an idea that maybe, just maybe, let's just say what we want to draw is, I'm going to switch it across. Alright, let's just say the circle that we want to draw, the arc, sorry, that we want to draw is, let's just say the arc that we want to draw is like 40. Yeah, let's just say the arc we want to draw is like a 40 arc like this. Right, an arc in and of itself, you see X and enter, an arc in and of itself is simply a small portion of a circle. So if it is that we were supposed to draw a circle at the center point of our arc, it would be like this. Yeah, so an arc is just like a cut off piece of a circle. But that will also mean that all I really and truly want to do is draw a circle. All I want to do is just draw a circle, that imaginary circle, because it's an arc, that just simply touches the two other circles. Yeah, and based off of what we were looking at before, we know that if this is an imaginary circle, or just for our arc, yeah, then we could simply just use the same idea that we had from before, where from center to center, and construct it, meaning just to know where it is. And that would be our problem. We do not know where this center point is. We do not know where this particular center point is. So everything in pink here is technically imaginary to us unless we begin to draw it. But what we do have is, they gave us let me just see if I could do this. They gave us the radius of the arc. So using our big brains, and referencing the knowledge that we know that there's an imaginary circle somewhere here, and if it is that we are just resting our circles on top each other, we know that the difference between this imaginary circle and the difference between our imaginary circle and this particular, in fact, let's start with one. The difference between this imaginary circle and this main circle that we have here is simply going to be the sum of the radius. And we have a radius here, and we also have a radius for this one here. So therefore, all I need to do is to draw my arc at the center, cut through the center to find the center. And because we have two circles, and we know that this circle is supposed to be touching the two of them, we have all that we need. So we're going to use this one here to figure it out. We're going to go a line here, and we're going to go 20. Let's do CXC. Let's write down our formula. So we know that we have radius 40. We're going to do 4. Wait. Oops. Nice. We're going to do 40 plus 20 is actually 60. Nice. Oops. 40 plus 20 is equal to 60, enter, escape. Nice. So now we have this. We know that 40 plus 20 is equal to 60. So we're just gonna take our center start, and then we're gonna use this as the center point, because we're going, remember, just in our example before, we're going from center to center. And let me reinforce something for you. If it is that I take this, and let's just say we know this to be 60, and I take an arc from 60 on the side, and I move it across, it passes through the center. So I'm going to use that idea, and we know that anywhere around this circle, is actually going to be the 60. So I'm going to use that same idea across here, where I do an arc, and I'm going to put the arc at 60, and I'm going to just make the arc there. Now, the hard part when we reach this point is we don't know exactly where. We know this is 60 away from this one, but we don't know exactly where the point is. It could be here, it could be here. So what we'll do is, we know, since we know this, since we know the radius of this circle, we're just gonna find, and we know that that circle is common between, you know, these two. We're just gonna simply do the same exact formula. I'm gonna use, what color shall I use? I'm gonna use orange, and I'm gonna say, hey, I know this one here, which is 50 radius, plus I now have to add up my radius, the 40 radius, which is our imaginary circle, and we're gonna have 90, and then we're gonna hit enter, and then we're gonna, oh, it's 90. So then I'm gonna grab my center start and use my center point, and I'm gonna go 90, enter, and cross it. So then what I have now is I have this point, and this point is now the center point, which is common between these two, which is this one, this one, and this one, and this one. Nice. We're almost there. Now, the important part that we want to know, since we're not, in fact, if at this point I was supposed to draw my imaginary circle at 40, in fact, let's do 40. What I would have is, I would see that it just touches the both circles. So technically, we're on the right path. But because we also know that, hey, it's not a circle we want, we know that there's an imaginary circle, it's actually the arc that we want, we need to know where that arc lies. And for that, what we're going to do is we're just going to take a line from the centers, as we know, boom, boom, and let's investigate a little bit while we have the chance to. Just for an example purpose, we know that distance from here to here is 40, which is correct for our arc, and the distance between here and here is 50, which is the correct distance for our radius on that side for this big circle. But if we do the same thing for here, we have the same 40, which is good. It means that we're on the right path. And if I use that over here, what do we get? We get the same R20. So we know that the idea that we were looking at on that side, it simply applies. Nice. So now we're going to exit, and we're going to go back. It's so cool. I don't even want to destroy it. But yeah, so now we know that these are good. These are basically good. So we're going to just remove our dimensions now, because we don't necessarily need those. That was just for our understanding. But now what we could look at is, we have 2 points here, P, Y, and T. We have 1 point here. We have another point right here. Now, since we have these 2 points, these are the 2 points where, technically, from our tangent questions, would be point of tangency, or where our 2 circles just have that one point in common, and that will actually be the 2 endpoints for our arc. So yeah, wow, we are back. I don't know how long I wasn't recording for, but at this point here, we actually have, 2 points, 1 and 2, for the points of tangency for the 2 circles. And I would say tangency because it's basically where the plane of the circle touches in common with these 2 circles. And what we're going to do is, we're going to come at this, and as we can see, it's distance 40, and we're going to go to this one, and then we're going to make this the main object outline, which is this. So see, that's how we basically get our arc. Let me just put this in main outline. Nice. And that's how we get our arc. Now we did this one here, and since we completed, well, we understood this whole theory here, and we know that, hey, once we do the arc on the outside here, it's also going to be let's just see this difference of 10 all around. Now what will happen, and I'm pitching this question to you, what will happen if we actually do center start end from, let's just say, 40? So we're going to start from here, and what I want you to note here is that it also is the same thing. Once we reduce the radius, we now can make an arc that also passes through this particular circle, and the idea still applies because we know this external, because we know this radius here, yes, as 40. That now means that we can find the common point between this one and this one, this circle and our arc circle, and this circle here and our arc circle as well. And once we find those two common points by making a slash, we could then do 40. Now let's do another example, and I'm gonna just drag this across here. Let me just put this here. Nice. Now let's do another example where we create a bigger circle. So we know that this circle is, let's just say, R50. Let's do a circle. Let's just say we want an arc, and I'll just do this here, one of 100. So this is going to be a very big arc. Yeah, so this is an arc of 100 radius. Yeah, this arc is going to be 100 radius, and we want this to be like an external curve. So the idea we're going with is this, simply this one here. If we have a circle that is at a particular distance, meaning this one is at 40, the center, difference between center is at 40 here, then all I have to do is minus the difference between the external arc, which is this one here, minus the 50 from the 40 in order to get the actual arc. So if I'm coming across here, I would say, okay, let's just see, we have this radius of 100. I'll first come here, I'll be text TXT, right, TXT. I'm gonna put across here, I'm gonna say 100 minus, because so you see it's the opposite of the plus that we did before. I'm going to 100 minus the radius of the big arc, which is 50, backspace, which is equal to 50, so that's 1. And then if we look at the other circle here, we have 100 minus 20, so we know that the other one would be 80. Awesome. So we know that. In fact, let's start with this one here first. So I'm going to start with this one. I'm going to go arc, and I'm going to go from the center, and then I'm going to go 50, because we would have just talked about that. Sorry. And remember, you either have to go outward or inward. So I'm just going to put all this stuff in gray so that it doesn't clash too much. I'm just going to put that in construction gray. I'm just going to gray it out. So now, because the arc is going to be facing this particular direction, our construction is going to be going in the other direction. It's something that you will understand. So I'm going to start from here. I'm going to go 50. Center start end. We're going to come from here. We're going to go 50. We're going to start at here, and then, sorry, yeah, we're going to go 50. We're going to come from here. We're going to start from here. We're going to go 50, enter. Then we're going to make this arc, and I guess it would pass on here. And then we're going to go from the other circle, and then we're going to take this one here, and we know that this one is going to be how much? 80. and then we're going to come and make this arc here. So now we can see that, again, don't mind the circle where it is, but now we're going to see that where the two arcs meet is this particular point here, and we're going to now use this as the new center point for our arc. So I'm going to click arc, we're going to use this as the new center point, and then what we're going to do is we're just going to go do the same 100, right, to get the arc across. In fact, let's do a line to find the common point of, let's just say, tangency. Let's find that center point, which is here. Nice. And we're just gonna EX enter, just gonna extend that line through, and then we're also gonna do the same thing on this side. I'll enter. We're gonna take it from, remember, we're taking it from the point here, we're gonna send it through the center, EX enter, and then we're gonna extend that through. You could use lengthen, and we're gonna pull that through. We're gonna say point because we know that it's gonna, one of them is gonna come here, POINT, and the other one is gonna actually be right here. So now, just to check it, we're gonna just check the dimensions. So we're gonna go from here and come down here, and we're gonna see how much it is. We're gonna understand that yes, it is 100, and it's just, this point looks a bit off. Alright, so I guess it would have snapped to the center point or the quadrant of the circle, so that's going to move that across. Nice. And now this one here is, so we have that here, which is 100 minus 50, and then this one here will be, let's check it, dimension. So from here to the external point, which would be 60, so we have that 60 there, and then we have the radius to the center of right here. Just take your time. It's actually going to be 20, which will give us that 80 that we desired. Awesome. Now since we have this, we're going to go center start, and we're going to click this line here. We're going to come all the way down to me here, and then we're going to do the arc. And what we're going to see is that it's just going to pass right through that point, and there we go. We would actually have our other outline. Nice. And that's how we do it. So we have one on the inside, one on the outside, and all we had to do was simply do our calculations and then incorporate it into the drawing. Yes. Nice. Awesome. Now let's go back to our main drawing and let's see how we can incorporate this. So I'm going to use my orange construction, and I'm going to do this one here first. So I'm going to switch this across to main object outline. Then after I switch it across the main object outline, I'm going to be, now we have all the dimensions on the outside. I'm going to be doing my construction. The next thing to do, of course, will be to do the calculations. TXT. We're going to go text. We're going to do our calculations in this particular corner here. I'm going to go, remember, if it is that we want it to be curved inwards, it's going to be positive. If it is that we want it to curve outwards, it's going to be negative. Yeah. So what we're going to do is we are going to take the radius from here to here, and then the radius for the object, which is 32, and we're gonna add them together. So if we go radius, which is 32, sorry, 32, let me just zoom in here. If we go 32 plus the radius of the other one, which is actually 27, we know that this is actually going to give us a value of 59. Yes, and once we come down here, so we're going to have 59 for that one. And once we come down, we could also calculate the other side as well, which will be this one here, and for that one it will be radius 30. So it will be radius 30 plus that 32. So we're going to do here 32 plus 50, my bad, plus 50 will be equal to, and we're just going to put that in there, it's going to be 82. Right, so I made an error here where I said that it was 50. No, it's actually going to be 32 plus, 30, which would then be 62. Awesome. So once we have these two numbers, what we're gonna do is we're gonna come with the arc. We're gonna come here. We're gonna do the first arc is going to be at 59, enter, cut. Second arc is going to be at center. Make sure we get our centers. And second arc is going to be at 62 and then cut. So this is where the center point is going to be. We're going to just make sure that our centers are aligned. Nice, that our centers are aligned. We're going to just remove these particular points. Nice, I'm just going to draw the L enter. I'm going to go from center point here to center point here, and then center point here to the center point as well here, and we're gonna go here, we're gonna click here, see exactly it comes up to 32, then we make our cut. If it is that your measurements do not align, just simply take the time to draw it over. Don't be afraid, you will make some mistakes. We come here, we outline, and then we do the object there. Now once we reach here, we're going to incorporate the second part of it, and now our formulas will change up a bit. So I'm just going to switch the construction to the layer. We're going to do our TXT, we're going to do our calculations, and our calculations, wait, escape, enter. Right, so now we're going to do our calculation, and our calculations would be 27 from 70, and that will give us 43. So half of this will be 27. We minus that from the 70, we get 43. Now for this next one here, which is 20, we're going to see 70 minus 70 minus 20, and we're going to have 50. Yes, so once we have these calculations, we're going to do the arc simply just here. We're going to do our arc, so we're going to start from, since it's the belly, we're going to do it internally, so it's going to be on the opposite side to where you want the curve to be. So to start, and we're going to click here again, and we're going to do, then the number is 43. We're going to cut, then we're going to do the other one, which is 50 arc. Then we're going to come here, we're going to do 50, and then we're going to arc, and we're going to cut. We're going to mark the point, we're going to draw our line between them, and then once we have that common line, which is here and here, now what we're going to do is we are going to extend it. We need to extend it through, so I'm going to click here, I'm going to click lengthen, because I would like to lengthen the line, extend it across to the outer radius, to the outer circle, same thing for this. Nope, let's do lengthen. So we're going to lengthen it to the, so we're going to do lengthen again. Nice. And once we have this, it passes through, we do a point, we mark it, we do another point, we mark the point, and then we simply just center start, and we're using the point of what I could only describe it as the point of tangency at this point. and then we're going to use that to pass through both points. And then this here would be your main object outline. Nice. And then from here you basically take the wheel and do your particular dimensioning relative to your question, and there you have it. This is how we construct. We use our whole tangent theory as well as playing around with some circle theory in order to construct this object. Again, even if I take this and I go here, this will be radius something. Same thing goes for here. So now it's your turn. I would like you to feel free to go through the exercise, complete it, and then send me a picture with your result. Remember to do your dimensioning and save your document. Have a good day.